Welcome back to part 3 of the GeoPython Advanced tutorial. In this part we're going to be talking about how you can create custom PowerPoint reports from your simulation results. Since Geodik 2020 we have included a library to create PowerPoint files. And we have done this with the general idea that you start with an empty PowerPoint file which only contains slide masters, which can, for example, include your corporate design as well. But the most important part is that you have predefined slide masters. And you can then, if you want to create a slide, you pick a master layout. For example, here, you pick this master slide up here, which corresponds to the layout of the slide that you want to generate. And then you see these placeholders here, where it usually says in PowerPoint, enter text or something. And you then go and replace those placeholders by actual content. So for example, you have this master slide here, which has a title placeholder, a picture placeholder, and a picture caption placeholder. Then you select this master slide, you give a title from within Python, you give a picture, and you give a picture caption, and add this generated slide to your presentation. And you do this one by one until your presentation is complete. So to illustrate how it works, here again, we see the master slides, or rather we have the one master slide, and we have several layout masters, as they are called in PowerPoint, that you can see here. This master slide doesn't really matter here, but what's important is that we have these layout master slides that you can define yourself. You can design them as you wish, or probably you already have master slides with your company logo, etc. But the most important thing for us when we want to programmatically access them is the numbering here. So you have to be aware that the master slides start numbering by 0. So the first one that you see under the first layout master that you see below the master slide is called layout slide 0, followed by 1, 2, 3, 4, 5, 6, etc. So when you want to generate a slide, you go into PowerPoint, you open up your master slides, and you check which slide you want to use, and you count the index of that slide and write that down basically. So here in this case, we have picked the layout master slide 1, and using Python code, we have replaced title by the text. This is the title text. We have replaced picture by a concrete PNG picture from disk, and we have replaced picture caption by this is the picture caption. Next, I want to show you how you can do this yourself. So please go back to Geodict. And first of all, please change the project folder. We've already prepared a folder which has some example files. So go to File, choose Project Folder, select Project Folder, and go to the root of your workshop materials. So here you can see next to the project folder that we've been using previously, we also have a folder called PowerPoint Reports. Go in there, so double click and click Select Folder. Next, I would like you to go to Notepad++, create a new file. You can do this by doing File, New, and save it as, so File, Save As. Go to the same folder, PowerPoint Reports, and save it as ppt1.py. Now what we're doing now is we're writing a Python macro basically from scratch. It will not have the header, the description, or the variables block, which are basically Geodict specific extensions, but it doesn't matter in this case. Geodict will happily accept it anyways. So we start by doing import gd_ppt. So we're actually using a well-known library which is called Python PPTX for this, but we found it a bit too complicated to use. So what we did is we wrapped around that library, we wrapped our own library, which makes it a bit more simple to use and which allows you to basically use this scheme that I described earlier by taking a master slide and replacing the placeholders in that slide. And we found that to be a bit more easy to use. But you can also always use the underlying PPTX library directly if you want, if you need more powerful constructs. So we start by creating a report generator. So rep equals gd underscore ppt report generator. Oh, by the way, capitalization matters here, so it has to be capital R, capital G here, and quote ppt underscore template.pptx. The reason why I asked you to change to this project, this other project folder, is that we have this ppt template pptx there, which is a PowerPoint file which contains some master slides, namely the ones that I showed you earlier. So we create a report generator which uses these master slides basically as the source for the layouts that you can use. So now what we want to do is we add one single slide. We do sl equals rep.add underscore slide, and we select the template 1. So that's basically below the master slide. That is the second template slide, the second layout master. Sorry. So we pick that, and now we start replacing the individual parts of the slide. So we have sl add underscore text title, comma, this is the title text. And so this title is what you saw in the master slide. Let me call it up again. Let's see here. So this title is what you saw here in the layout master slide. This is actually, you have to give it some keywords so you can address this from the Python code. So normally it says put some text here or something. So it doesn't have any meaning usually. But here you have to give a keyword basically in your layout masters, and this is what will be used to address this individual design elements from within Python. So it's title, picture, and picture underscore caption. So these are the three elements that we need to replace. So let's go and finish that. So we added our text. Next, we want to add the picture. And the placeholder is called picture, as you saw. And replace this by example PNG. So this actually has to be an image file that has to be on disk at this point in time when it arrives at this line. But of course, I mean, we saw earlier that you can create plots. You can create a plot and write it to a PNG file. Of course, nothing stops you from up here creating a plot or multiple plots, and then taking these files and inserting them into a slide. But in this case, this example PNG is a file which I've already prepared. So in this directory that we changed to, we have this ppt template, pptx, and we have the example PNG as example files. So, and last but not least, let's add the picture caption. So add text, picture caption, and this is the picture caption. Now, the slide has already been added to the presentation at this point. We have filled it by replacing all the placeholders. And now, finally, we only need to save our presentation. So we say rep.save, and we call it example pptx. So of course you could be adding more slides here. You could go again, you could here go SL or SL2 equals rep add slide, and even use a different layout master if you wish, and then replace the placeholders of this slide, etc. as often as you want before saving the presentation. And now save this file. And now let's go to Geodict. Open the macro execution dialog. So macro, execute macro script. That's already here. And now you should see that the new project folder should be listed here, namely PowerPoint reports. You can unfold it and click refresh if necessary. And there you should see the ppt1.py. So select it and click run. And this is a very quick operation. Now we go to the Explorer. We go again to the base of the workshop materials. Here we have PowerPoint reports. And here we should find example PPTX. So if I open this, you can see the slide that I showed you earlier. So Python has programmatically replaced this title placeholder by this is the title text, literally, and likewise the caption. And it has replaced this picture placeholder by the PNG file from disk. And again, let me show you the master slides. You can see them again. You see this master slide, which we don't care about in this case. And this is the layout slide 0. And this is the layout slide 1. If you remember, this is the one we used, the 1 in brackets. And here we replace title, picture, picture caption. And the actual the template file that we were using is actually just basically an empty presentation of the same type of this as this presentation, which only contains the master slides. Now, before I close this presentation, let's have a quick look at a certain master slide that I want to use in the next step. So the slide masters, we're going to be looking at slide number 7. So this is 0 again. So 0, 1, 2, 3, 4, 5, 6, 7. And here we can see that we have a title, a table, and a picture. And in the next step, we're going to fill out this slide, basically. Now remember that in the file workshop5.py, we were plotting the permeabilities against the SVP. And we now want to create a report slide based on that. So we go back to Notepad++, and we start by opening the workshop5.py. So go to File, Open, and go to the old project folder, which was called Project Folder, and open the workshop5.py. Again, you can also take, if you weren't catching on, you can also take our version of workshop5.py, which can be found in the M2M results folder next to the project folder. So we have workshop5.py, and now please save this as, so File, Save As, and now back to the PowerPoint reports folder next to project folder, and save it as PPT2. Okay. Now we can fold this function again. And here we still have our code, which produces the plot and saves it as permeabilities.png. And now we just go to the very end of the macro and we continue. Import gd.ppt again, so we get our PowerPoint library. Again, rep equals gd_ppt.report generator. So again, we create a report generator object, again based on ppt_template pptx. Use the same template slides. Then sl for slide equals rep.add slide. But now we are basing it on slide number 7, as I mentioned earlier, which has a title, a table, and a picture placeholder. And we begin by replacing the text for the title. So we do sl add text, title, and we write flow permeability versus SVP, because that's what we want to show in this slide. And then we can already add our picture because we have already produced that picture in the code above. So add_picture, and we replace the placeholder called picture by the concrete PNG file permeabilities.png. Oh, sorry, I put an underscore, there should be a dot. So sl.add_picture. So next, as I showed you, there was also a table placeholder, and um, that table is going to be a tabular representation of the permeability versus the SVP. So we need to construct this first. We have table data equals list, empty list, and this is going to be a list of rows, basically, of table rows. And now we're going to do a parallel iteration. So as for SVP, comma perm in zip SVP values, comma perm values. And remember, this SVP values is the list of SVP values that we tried. And the perm values, after this for loop is completed, is the list of the corresponding permeability values. And what this does is it iterates basically in parallel through both lists. So for the first iteration of the for loop, we will have the first SVP, which is 5 in this case, and we have the corresponding permeability. The second time around, we will have the next SVP and the corresponding permeability, so 10 and the corresponding permeability. So it always iterates in parallel. So it runs as often as there are values in SVP values, which is the same number of values as in perm values. So we do this, and for each pair of values, we add to our table, we add a row to our table. So we do table data append, round brackets, and the other brackets, sorry, SVP, comma, F, quote, perm, colon, 2E, curly brackets closed, quote, and brackets closed. So this is another another construct. I showed you the format strings earlier, which allowed you to replace some parts of a string by a variable value. But oh, sorry, I forgot a dot here, so it should be colon dot 2e. So this is a special syntax which allows us to specify how numbers should be formatted. In this case, it means format the number with 2 decimal places in exponential notation. So if we don't do this, we get very long strings of digits basically, which are hard to read. So next, we're going to replace the table placeholder, which is the last placeholder on that slide, using sl.addTable. The placeholder is called table. We replace it by the table data. And we can also specify here a horizontal header. So horizontal underscore header equals SVP percent and flow permeability in square meters. So what this does is basically just titles for the two columns. So this is just strings which get displayed on top of each of the columns. So our first column is the SVP column, so the first element in each row, which is the first column, is the SVP. The second column is our permeability. So this has flow permeability as the header. Now our slide is complete. We have replaced the 3 placeholders, the title, the picture, and the table. And now we can save our presentation. Again, it's just a single slide in this presentation, but of course it can be easily extended. So we save this as, let's say, plot and table.pbtx. Now let's hope we don't have any typos and save this file. Go back to Geodict, execute macro script, refresh if necessary, and select the ppt2.py and run it. Again, you probably have to click override a couple of times. And now we go to the Explorer, go to our PowerPoint reports folder, and there we can see plot and table.pptx. Can open it, and it looks like this. So here you can see that we have rendered a plot and inserted it instead of a picture placeholder. And we have taken the same data and inserted it as a table here with a horizontal table header here. And if you just change the master, you can change the layout of the slides by just changing the master slide. For example, you could swap this around in the master slide, just run the same Python script again, and the table will be on the right-hand side and the graph will be on the left-hand side. So even someone who doesn't know about Python programming can change the layouts, for example, just by modifying the master slide in PowerPoint. Now, let me give you a short overview over the supported content types, the types of content that you can place into a PowerPoint presentation. I'll show you these slides. And by the way, this whole slide deck that I show you intermediately is included in your workshop materials. So this is this you can use for your reference. So you've already seen the SL add text function, which replaces a placeholder by a given text. And one thing you haven't seen is the optional argument called font size. So here you can experiment with different font sizes, and depending on what number you specify here, the text will be larger or smaller. Add picture we've also seen. Here you give a placeholder name and a picture file, and the placeholder will be replaced by the picture file with that name from the disk. And table we've already seen as well. You specify the placeholder, the table data. So that is the list of the rows, whereas each row is a list again. So you have a list of rows, and a row is a list of basically the elements in this row. And the optional arguments, as you can see, a horizontal header and vertical header, which can be specified. We've only specified the horizontal header in our example, but you can also have a vertical header, as you can see here. So titles, number, letter, and first row, second row, etc. So these are highlighted then. And as in the text example, you can also specify a font size. Last but not least, you can also add movies, for example, movies that you have rendered from Geodict. So for example, if you render an MP4 video from Geodict, afterwards you can go and say sl.addMovie and replace a placeholder by this MP4, sorry. And in this case, this placeholder is called picture because you can use any layout master which has a picture placeholder. You can replace that picture either by a picture or a movie. So in this case, we just use one of the standard slides and replace picture by this example.mp4. So I guess we can agree that we did enough typing for today. So let me show you two more examples that you can just simply run and maybe later use as a reference if you want to dig deeper into it. So let's just go back to Geodict. And change our project folder once more. Go to File, choose Project Folder, select Project Folder. And here we go to the folder FlowDict Report inside the PowerPoint Reports folder. So Workshop Materials folder, PowerPoint Reports, FlowDict Report. Double click, click Select Folder. So this is an example. Let's go to macro, execute macro script, see FlowDict report here, unfold it, maybe click refresh. There's one utility macro here, which we don't need to care about right now. And there's two macros here. Step 1, create and simulate, and step 2, FlowDict report. So this basically does the kind of splitting that I talked about earlier, that you have one macro which does all the heavy lifting, which can run overnight or over the course of a couple of days. And then you have a second macro which collects this data and creates the report from it. So you can easily change the second macro and run it again within seconds to just change your report. So this folder already contains the results from step 1. So I would like to ask you to just run the step 2 here. You could run step 1, but it takes a couple of minutes. So let's just go and click step 2 and run it. Now we go to the Explorer again, go to Workshop folder, PowerPoint reports, and then the subfolder Floatic report that we changed to earlier. And here we can now see a new PowerPoint file called Floatic report. And this again consists of 2 slides. So the first slide, let me just zoom this. So the first slide compares 3 different structures, as you can see here. These are fiber structures with different solid volume fractions, 10%, 40%, and 70%. And it computes streamlines. It computes the flow velocity through it, and then it renders streamlines, which shows how the flow wanders through the structure basically. And you can see that the velocity is reduced here because the dark blue corresponds to a slower velocity in these denser structures. And on the second slide, you can see a plot. Oh, sorry for that. On the second slide, you can see a plot of the pressure drop along the Z layers, and again the table of SVP versus total flow permeability. These plots here are basically produced by the flow solver itself. So if you have a single flow simulation, you get a pressure drop for that structure, which is a single curve here. But you can also combine these curves by combining the GDR results for 3 different flow simulations, and then you can lay them on top of each other. I can show you this. In Geodict. So go to File, Open Results, GDR. So we go to this Floatic report folder, we should already be there actually, and we open all these Lear-Stokes results files at the same time. So shift click to mark the whole range and open them. Then we see the result viewer here, and we can select them all and click Combine Results here. Then just click OK. And we get a new GDR file, and the plots in this GDR file, they contain the combination of the corresponding plots from the individual files. So if we go to a single file, let's say the 10% one, go to the plots, we see one single pressure drop curve. Again, for the 40%, same thing, pressure drop along Z, and 70%. But in this combined GDR, we will see all of them layered on top of each other. And if you do this, if you combine this GDR and then you save this image here as a plot, the whole thing will be recorded in the session macro as I showed you at the beginning, and you can copy that to your Python macro and do the same from within Python. And that's what this file does that I showed you, the step 2 that we ran. Now there's one last example that I would like to show you that you can just run again. It's the same as before. But for this, I would like you to please close and restart Geodict, because I realized there's an error in a file naming which prevents us from running this right after each other. So just close Geodict and start it again. And now once more we change the project folder. So we go to File, choose Project Folder, select Project Folder. And before we were in Floatic report, now we go back up once to PowerPoint reports and go into Filter Efficiency report. Double click and select folder. Now again, we go to the macro execution dialog, execute macro script here. And unfold this filter efficiency report. And again, we have two scripts, step 1 and step 2, with the same split that I showed you earlier. So step 1 does all the heavy lifting, the computation, and step 2 then just collects the results, aggregates them, and generates a report. Again, we have the results for step 1 already present in this folder, so just select step 2 and click Run, please. So what this does, it generates 3 different fiber geostructures. But in this case, all these structures have the same solid volume percentage, but they have a mix of 2 different fibers, a thin fiber type and a bigger fiber type. And the only thing that we are varying is the proportion, the volume proportion between these 2 fiber types. And then we analyze the effect that has on filtration efficiency. So after running this macro, go to the Explorer again, go up to PowerPoint reports, and go to Filter Efficiency Report, our new project folder. And there you should see FilterDict Report PPTX. Double-click it. And as you can see, again, we have a report with 2 slides. And we have 5 different structures here, where we can see that we have thin fibers in green and thicker fibers in red, and we are varying the proportion of these fibers. So the green fibers are 14 microns, the red fibers are 14 microns, the green fibers are 4 microns. Here in this structure we have 100% 4 micron fibers. And on the other end of the scale, we have 100% 14 micron fibers here. And you can see, because of the different coloring, how the proportion varies here. And we have also sliced away half of the structure, so you can see how well the particles penetrate inside the structure. So you can see here on the left-hand side that when you have 100% of the thin fibers, then, as one would expect, the particles do not penetrate very deeply. But we can see that the smaller particles penetrate more deeply than the bigger particles, which immediately form a cake on top of the fiber structure. And if we then increase the amount of thick fibers and likewise reduce the amount of thin fibers, we can see that the particles penetrate more and more until we only have the thick fibers, where even relatively large particles penetrate relatively deep into the structure, and we can see that a lot of particles are not filtered anymore. Whereas in the first example, we can see that most of the particles are filtered. And to get a numerical representation of that, we can also do a plot. Here we can see the pressure drop of the filter medium depending on the fraction of thick fibers. So corresponding to these structures, 0% thick fibers on the left-hand side and 100% thick fibers on the right-hand side, we can see how the pressure drop changes. And more interesting, down here, we can see the filter efficiency curve depending on the diameter of the particles. So we can see that, of course, as one would expect, for the very largest particles, all of the structures basically have an efficiency of 100%. But when it comes down to the very small particles, then only the structure which has only thin fibers is able to filter any respectable amount of these very small particles. And all the other structures let a lot of these small particles through. At this point, let me just briefly touch on some further topics that are outside the scope of this workshop, but might be interesting to you. So first of all, we usually have a geodict-centric approach when writing these GeoPython macros, which means that we have geodict running, basically controlling the whole thing. But if it fits better to your workflow, it's also possible to run geodict on the command line, give it a macro, and set some values for the variables. So you could have a Python macro with several variables. Again, please see the beginners workshop for how to use them, which you can specify from the outside, like using geodict as part of a pre-existing workflow, for example, in a batch file or in a shell script, or even calling it from another Python script. So that's also possible. And there's also a lot of other geodict API functions, which you've only seen a few of them. These are the functions which start with gt dot, which actually which actually are the core, if you will, which make the differentiate GeoPython from normal Python. Namely, a normal Python interpreter does not provide this Geodict API. And these APIs allow you, for example, to access the structure itself, so access the voxel image, and the simulation volume field. So, for example, the velocity vectors or the absolute velocity in a volume field. And it does so. It does so with a relatively high performance because you get access via NumPy arrays, which allow you to quickly do computations, for example, on these images. And you can also manipulate gut objects, as we call them, which are the analytical objects. So for example, if you generate a fiber geostructure, you not only have the voxel image, but Geodict also still knows the underlying fibers, basically um, um, like a chain of cylinders, if you will. And you can manipulate these objects and therefore update the voxel image as well, and also create new objects if you want. So you can create and edit all of the object types that Geodict can create. And you can also write, for example, image filters for import geo in Python using NumPy. And let me just quickly show you how you can access the help functionality, which gives you the whole list of functions that you can use. So let's just quickly go back to Geodict. In the macro execution control itself, there is a Geo API help button down here. If you click that button, it should open an HTML file. Let me just get my browser. It should open an HTML file which shows you a quick overview of the functions that you can use in Geodict. And these are growing every time. So, for example, let's see MSGbox. That's the one we used a lot here. MSGbox, and you can see the parameters of that function and their type. It takes a text, a string, and what the function returns nothing. And here a quick description of what the function does. For example, you can also access the individual particle trajectories after running a filtered simulation or something like that. That's really interesting. You should probably, if you're interested in that, have a look at this list and see if there's anything that you can use. Beyond that, we also include some additional libraries in Geodict, namely NumPy, which, as I said, allows you to do fast numerics in the style of MATLAB, so basically matrix vector style. For example, to run statistics on result fields or combine result fields. Or SciPy, which is basically it's built on top of NumPy and gives you even more methods for scientific computation. For example, it has some optimization routines, which we also use ourselves, which could be interesting if you run an optimization beyond the simple bracketing scheme that I showed you earlier. Then, of course, there's Matplotlib. Again, you will find a lot of documentation about all of these libraries online, especially the first three here. Then there is XLSX Writer, which allows you to create Excel files pretty easily. Then there's the TensorFlow library, which we also use for FiberFind AI and Geodict AI, which is a deep learning library. And then there's Pill, or rather Pillow, depending. I think it was renamed at one point, which allows you to do image manipulation. For example, you can do a collage of several plot images or something if necessary, or several 3D images and put them next to each other or crop them or whatever. In conclusion, we have shown you how you can access your simulation results programmatically using GeoPython, how you can restructure your GeoPython code into functions so you can call it repeatedly from within a loop, for example, and how you can perform a simple automatic material optimization using a bracketing scheme. And last but not least, how you can create plots and how you can create PowerPoint reports based on your simulation results. With that, I would like to thank you for your attention, and we're going to have another 15 minutes break where I'll be happy to take your questions. Thank you.